So welcome to my lecture series. So today we discussed applications of superconductors. So in that applications of superconductor, we discussed magnetic levitation. So the magnetic levitation works on electromagnets on underside of the train, pull it up to the ferromagnetic starters on the track and levitate the train. So the magnets on the side keep the train from moving from side to side. So a computer changes the amount of current to keep the train 1 centimeter from the track. So this means there is no friction between train and the track. So the principle of magnetic levitation: if two magnets are mechanically considered along a single axis, for example, and arranged to repel each other strongly, so this will act to levitate one of the magnets above the other. So another geometry is where the magnets are attracted but prevented from the touching by the tensile member, such as a string or cable. And so that materials are used magnetic levitations is: for magnetic levitation to occur, a permanent magnet has to be in a place as diamagnetic object. So permanent magnets include niobidium magnets, samarium cobalt magnets, and alenigo magnets. Diamagnetic material is a material that is repelled by magnetic fields. So levitation system power supply: the batteries on the train power the system, and therefore it still functions without propulsion. So the battery can be levitated the train for 30 minutes without any additional energy. So linear generator in the magnets on board the train use the motion of the train to recharge the batteries. So levitation system uses less power than the trains are conditioning. So that system consists of aluminum 3-phase cable winding in the starter packs that are on the guideway. So when a current is supplied to the windings, it creates a traveling alternating current that propels the train forward by pushing and pulling. So when the alternating current is reversed, the train brakes. And different speeds are achieved by varying the intensity of the current. So only the section of a track where the train is traveling is electrified. And applications information. So first one is the safety. The trains are virtually impossible to derail because the train is warped around the track. So collisions between trains are unlikely because computers are controlling the train's movements. And maintenance: there is very little maintenance because there is no contact between the parts. And so comfort: the ride is smooth while not accelerating. That economic efficiency is the initial investment is similar to the other high-speed railroads. So operating expense or the half of that of the other railroads. So a train is composed of sections that each contain 100 seats, and a train can be between 2 and 10 sections. The linear generator produced electricity for the cabin of the train. So that for successful levitation and control of all 6 axes, that means degrees of freedom, 3 translational and 3 rotational. Yeah, combination of permanent magnets and electromagnets or diamagnets or superconductors. So as well as attractive and repulsive field can be used. And the primary ones used in magnetic levy trains are servo stabilized electromagnetic suspension, that means EMS, and electrodynamic suspension, EDS. That speed the train can be travel at about 300 meter per hour, and for trips of distance up to 500 miles, the total travel time is equal to the planes, including check-in time and travel to the airport. So it can accelerate 200 per hour in 3 miles, so it ideal for short jumps. Thank you. We discuss in next session.